Hello there, math fans. Going to talk about a problem that occurs in a couple of our sections of Math 120. It's this Allyson and Adrian attached by a bungee cord at the ankles. One is going north, one is going west. And the real point of the question is just to practice working with distance and rates. And actually, it's not meant to be a big problem. But I do have a bunch of people asking about it because it appears in two sections. So there's some anger and frustration about it. And so I thought I would just say a few things about the overlying skills. Because I have people coming to me and say, you need me to teach how to do this specific problem and how the exact steps to do all Allyson and Adrian problems. And it's not like we're doing Allyson and Adrian bungee problems all term. We're working with speed and labeling. So I think the goal is this bigger step. So I hope I can kind of let me know if something like this is helpful. My goal is always to try to help students see where their confusion is so you can put a name to it. Because the questions I'm getting are, I don't have any idea how to do it. And that's not helpful to me because I would like to get us a little more specific. I already posted about this question. I think perhaps some of the people asking about it haven't checked that out. I even made an animation of me connected to Harry the Husky about this. And I talked about how the real skill is labeling the coordinates. That's actually the skill. So it's a couple really small skills. Now, there was a challenge in Chapter 2 about finding when you hit that corner. But that was the challenge. Chapter 4 should feel like a celebration after Chapter 2. This should be a really short question. So let's just recap. The question says, Allyson is going one way, going north. Adrian is going west, and it gives you the speeds. Now, everybody has random numbers. They're not all the same. Here, one person, Adrian's going 9 feet per minute. In this example, I just grabbed the one in my numbers. And Allyson is going 10 feet per second. We should be able to, at this point, we've done this quite a bit. We should be able to label their locations. Because the homework stepped you through it. It said, where are they in 1 second? And you should know that in 1 second, Allyson would be at 0, 10. And in 1 second, Adrian would be at -9, 0. So if you're not quite getting that piece, you're missing these two skills. T is our time. And the skill here is that distance is speed times time. But I'd argue we've done that quite a bit in many problems. The challenge was that the time was unknown, so we just called that T. But I made a whole series of examples where I said, okay, the moment you see all that, we now should be at a point where we can say 0, 10 T. In 1 second, there'll be 10 feet. In 2 seconds, there'll be 20 feet. In 3 seconds, there'll be 30 feet. And that was this skill, getting used to having a variable there. Okay, so we can label Allyson's location. So in any of these problems that have to do with something moving around, we should label the locations. So I'm extending. To me, these are the skills that are hopefully becoming automatic. Adrian started at 0, 0 and is moving to the left. That's why I was labeling it negative. And so this is going to be -9t. And the one nice thing about this problem is all the units matched up. So you didn't have to do any conversion. That was an added challenge on earlier problems. And then the other thing is distance. We now know the distance between them. You had a series of questions where you did this. Cars going different ways. We saw a bunch of these. The distance between 2 points. So this is like my, and it doesn't really matter the order in which I label them, but this is like my x1 and my y1. And this is like my x2 and my y2. So you should realize this question was all about distance. The bungee cord was just to give you something to think about that could actually get longer or shorter. But really the question was just about the distance between them. So the distance between them is going to, in general, is going to be this. And this is what you did in Chapter 2. So in Chapter 2 you did 0, minus, negative. Now you even found the formula. So this is getting you thinking about how to build up a formula. They had you first do it with numbers. Whereas in 1 second, whereas in 2 seconds. So this is where what we should have left Chapter 2 with. And the question said, how far apart are they at a certain time? And then it asked various things about when are they 30 feet apart? And then you found out that it touched the corner around 6 seconds. Those are all things you did back in chapter 2. Okay. So then you get to chapter 4, and it asks you a new question. And it even gives you a new picture. Okay, so let's pull up the new question and read it. The other thing students are struggling with is reading questions carefully. That is a math skill. It's part of the math. So let's play this game. Adrian starts moving at 5.5 seconds, but Allyson keeps on moving at 10 feet per second. So what does that mean? Well, we can label. So nothing has really changed. We already have this at our disposal. The first thing I would do is I would say, well, where is Adrian at 5.5 seconds? We already have a form before. I didn't do this before. So these are the things we should be doing, is we read a question and we say, okay, what does that say? Let's label it. So Adrian's going to be somewhere over here. And I have it's negative 49.50. That's how you read that. Allyson's going to keep going. So at that point, she'll be somewhere far up here probably. And she's just going to keep going. But we can label it 0, 10, t. And we kind of know from the earlier question that after 6 seconds, it'll start to bend around this corner, which sounds scary. Sounds like there's a lot to do. But we know that corner is negative 20. We spent a lot of time with that in the previous assignment. So I find it actually nice that they build on each other. But anyways. Okay, so then what does the question ask? Compute the length of the bungee cord in 7 seconds. And it gives you a picture in that problem. Picture something like this. So at 7 seconds, you're going to know where everybody is. Adrian's going to be at that point where they stopped. Allyson's going to be up here at 0.70. And the picture was partially a hint if you looked at the problem, because they were saying, hey, look at it, it's bending around the corner. So to me, it's not like there's a skill. This was read the question, identify what it says, and label. And the question is saying, how long is this? So it's not like I mean, the steps are always to visualize, label everything, translate, and solve. So the question is saying, how long is this? How long is it from here to here, plus there to there? You can't use this formula now because of y. Because Adrian's not moving. But you can use the distance formula. So you're going to compute this distance. You're going to compute this distance. Add them together and be done. So the confusions might be, well, how did I know it was 0.70? Well, that goes back to knowing what this 10 feet per second means. How did I know I needed to compute the length? The question said length. How did I know it was bent around the corner? Well, that builds on the previous section, but they gave you a picture. How did I know that this was negative 20/30? Well, that was given in the picture. So the reason I'm saying all this is I would like you to try to think about where in that story are we getting mixed up. So when you read this question, you're doing the homework, and it says, Adrian stops at 5.5. And then they give you this picture, and they say, how long is the bungee cord? Where are we stuck there? That's the part I want us to be thinking about. Okay, so then there's another part of the question that says, when is the bungee at maximum length? And maximum length from the previous section and in the problem itself, I didn't copy all of them, is 90. So the whole point of this question is not to say there's like a set method. They're trying to help you. We just figured out that the distance is going to be... So problems like this, that are asking kind of the same thing but in reverse, you can do side by side. So we have a question that says, how far is it from here to there to that point? So it's two different straight line distances. From -20, so you just got to buckle down and compute. -49.5, 30 minus 0. And I need to go between those 2 points. 0 minus -20. There's no way around it. I had to read the question. This is not like something we're going to regularly do. We are going to use the distance formula a lot. We're not going to add two distances. So we got to separate from knowing this specific problem and more about knowing the skills and reading the question. So the first question was saying, what is this? And the second question is saying, when is this 90? And you have to think about, well, what's changing? The only thing that's changing is this. So to me, that's not so bad. We can do the exact same problem. So this is not, you're using your own work that you've done to inform what you're going to do next. The problems do go together. So what's not changing? This is not changing. This is not changing. The only thing that's changing is going to be this, because Allyson keeps going. So you have to think about, what does that change in the story? And then can you solve for t? It's actually not that bad. So the chapter 4 version of the Allyson and Adrian question is actually really short. I'm almost done with what I have written there. So I'm going to let you think about that some more, but as I'm saying, that problem will be short. Don't let the fact that in chapter 2 we did a problem that had this challenging part at the end affect your view of this one. This is really about labeling points and computing distances. All right, I hope that helps.